When you launch the machine learning application, you'll see a screen similar to the below. Select Launch. So to get started with Amazon Machine Learning, this will be the standard setup. You start the creating your first machine learning model. If you don't have the data ready, you can use a sample data set. So this is really great because it gives you some stuff to be able to practice with within Amazon. So AWS will next ask you where your data is located. So select S3 and type in the bucket name that you created in the previous example. So you can use the version 2 bucket, the MSDS 7330 original bucket. It's really up to you. And obviously you can't use those buckets because those are ours, but whatever bucket you've actually created, feel free to use either one. The first step to create an ML model, an ML stands for machine learning model, is to show Amazon ML your historical data. This data must contain statistics about your data, your training data as well. So this is a couple screenshots that you can actually follow through where you can try out your Amazon ML. And if you don't have your data ready, you can actually get some of these other data sets. So import your data to create the Amazon ML data source. And in your location, make sure that is where we have, this is where we have that iris.csv data set. So the next step will ask you to validate your metadata. Ensure that all categorical attributes are categorized as such and numeric values are classified correctly. So all your metadata will be your column headers essentially. So to make sure that everything, all your attributes are defined the correct way. It's really important to make sure that if you do have numbers, make it numeric. And if you do have words or letters, make it categorical. This is something that will throw an error if you don't do this correctly. So once your schema is correct, select Next. The next task for you is to select your dependent variable. In this example, we are interested in predicting the species categorical variable given the continuous variable seen in the screenshot, the sepal length and the sepal width, etc. As a reminder, if your data has an ID, ensure that you specify that in the metadata. Our ID attribute is not a predictor, so we need to exclude it from the analysis. Before we can run our model, we need to select how to determine the training/holdout data. Remember that this file is sequential, meaning all the same species are grouped together. Do not accept the defaults or your validation results will be off. The default validation method is to read 70% of the observations and set them as training and use the bottom 30% of the data as validation. Set of defaults, follow directions to randomize the data. So in the step 2, in step 2 of the ML model settings, you can use this to automatically suggest ML model settings right here. So you have your multi-class, your model target, what you want, so species, the ML model name, whatever it is. For us, it's iris.csv. And then select the training and evaluation settings. So this is something where we can actually break up that one data set, train our data on a specific part of it, and then try to predict the other part. So for us, we're training on that 70%, and then we're going to try to predict the other 30% and see how that actually works. So the AWS machine learning will give you an idea of progress. The steps are to read in data from S3, split the data, complete the training step, validate, and give results. This will give you an idea what to look for. So again, this is going back to when we do have that one data set. We can actually split that up, block it out to 2 different sets, one for training, one for testing. Once we train our model, we can validate it, and then it'll actually give us results. In this below screenshot, you can see this process for the evaluation, what the model actually is for the CSV, and how it's all actually completed. So this is what it should look like. And we're going to go on and kind of see a little bit more about how this actually worked. So we want to know how our model performed. So click on the evaluation section. Revisit the previous slide if you need to track it down. I'll just call it evaluation ML model iris. I can go back real quick just to look at this, where it has evaluation with the model's iris. That's what ours looks like, just as a refresher. So on the left, you can see a screenshot of the output, but we see that our model performed very well on the validation data set. We have a few misclassifications, but not many. The F1 score is defined as the weighted average of the model's precision and recall. 1 is the best and 0 is the worst. This is paraphrased a bit from the sklearning documentation. We hope you now see the power of S3. We want we went from a very simple way to store lots of data to building classification models. There's so much more that we can do with S3, ranging from IoT applications to RD BMS. You now have enough to explore. Good luck. So if we do look at the values, the predictions, we can actually see that from the correct prediction is 100% within 3. But if you want to actually go down and see what we're actually doing, the F1 is showing a very high level of prediction with well over 80%. So, or 0.8. But this is just a little quick overview, a very simple example. I think we can all follow along.